Building on the previous demo, we had multiple rows across many blocks being updated from one node, that is node 2, and then queried from node 1, and then node 1 having to wait on global cache wait events because the blocks had been made dirty at node 2, and node 1 needed to fetch the current the consistent versions of those blocks. So here I'm going to run a demo with just two rows in a small table. Both rows are in the same block, but Oracle allows row level locking. So each node will be locking its own row, which is fine. So I have two rows inserted from node 1 and node 2. So this is the query on node 2, 0.001 seconds, and this is the query on node 1, 0 seconds. And if I look at the current events, okay, node 1 has had no events. These two GC wait events are just my prior setup, so hardly anything, 1 microsecond. So I will update one row on node 2. TS call is the timestamp column, and data call is my data value itself. So I'm going to set a new timestamp. These are the old timestamps. I'm going to set a new timestamp and change the data value. So if I run the query again from node 2, you can see it's been updated in node 2, and now node 1 still has the previous version of that row in that one block. So if node 1 runs the query, it still has previous version because node 2 has not committed. Okay, so it's still got a read consistent version of that row because node 2 has not committed. But did node 1 have to wait? Yes, there was a slight wait here. To get a consistent read of that block, it found that that block is busy, that is been owned by node 2, so it had to wait for that. Let me try to run the query again, and then check for the wait event. So this wait event is being incremented, right? This only GCCR block busy is being incremented. I want a consistent read of that block, and the block is busy. See, 3 waits. It's waited 3 times. The 3 times that I queried for a consistent version, I got 3 waits. Let me query one fourth time. Okay, so there was one wait event. The time is very low because it's just one block, and it's not taking much time to transfer that block from node 2 to node 1. So it's microseconds. It's just 7 microseconds. So I'm just talking one session, one block, but you could look of a scenario where you have hundreds of sessions and thousands of blocks. Now let me commit this update here, and then node 1 runs the query again. So now node 1 should see the new version of that row, which is this update statement at 333. Previously it only saw 325 version. Okay, so now it has seen the updated version of that block. But what wait event did it encounter? This one. This wait event got incremented. GCCR block 2 way. It had to ask the resource directory, the global resource directory, where is the current version of the block, where is the consistent version of the block, and then fetch it again. Now if I were to run the same query again on node 1, let's see if the wait gets incremented. So again, there's one more time where it has to ask where is the current version. Okay, run that query again. now there is no change. See, so for there were two times after such node 2 had done a commit, there were two times when node 1 still had to wait on this event, just this event, this gccr block 2 way. See if it's, yep, so there's been no increment in the weights. Let me update the row again from here, put a new timestamp, set to new update and not commit, so I'll just update. So the session in node 2 can see its own updated row, right? So 336 timestamp, but node 1 will still see the older version of that row, 333 timestamp. Okay, and let's look at the wait events now. So we are back to this one, CR block busy, wait. So now it's back to the same old behavior. The block has been modified at node 2 but not committed. So every time this guy node 1 wants to read the block, it will have to incur one overhead of waiting on this event from 5 to 6. Run the query again, 7. The query again, 8. Let me do a commit from here, then I run this query. So what change has happened? Now we're back to this GCCR block 2-way waits. Okay, so this wait is no longer occurring, but it's just verifying with the resource directory, asking which is the current version of this block which has been committed and where do I get it from. And so node 1 session now is waited for this on this event. Let's run the query one more time and check for the wait event. So once again this wait event has incremented. A third time, and now it's no longer incremented. So now node 1 knows that it's got the current version of the buffer. The buffer is now a clean version, there are no dirty changes to it. Both instances have the current version of the buffer. So this is a simple demo where you have a row being updated by node 2 and then node 1 having to wait on it of every time it queries that updated that table containing that block. Remember, it doesn't matter if it was querying for its own row. Let me just demonstrate that again. For example, here I do a third update. Okay, so I've updated this a third time. So now I got 339 and third update. Now I'm going to run this query for my own row. I'm interested only in my one row. I'm not interested in this row 2. I'm interested only in row 1. So do I wait for any event? Yes. Now there is some more waits occurring. This one is gone up to 10 because I got the block containing that my row, but I had to verify whether it's a consistent version again. Remember, instead of a full table scan, maybe I'm just querying for one row, but I still have to wait. So you see these two waits. Let me run the query again. I just want ID call 1, and then what am I waiting for? I'm back to GCCR block busy wait. So the one time this one change happened because I switched from full table scan to for all rows to a full table scan for one row. So the query also had to be repassed. So I had to identify the block and verify it. But now I'm back to this wait event. Remember, I'm not interested in the ID call 2 row at all. I'm interested in ID call 1. But the block that contains this one has been modified for ID call 2. So even though I'm querying for ID call 1, I keep waiting on this event. Let me run this query one more time. Okay, so I keep waiting on this event. So let's see again when node 2 does a commit. And then I query here. So what is the change to the wait events? Now I'm back to this change. ECCR block 2A. I would advise you to go and look at the documentation. I'm not going to explain each of these wait events, but you can go and look at the documentation. These wait events are explained in the administrator's guide. There's a separate section on wait events. These are not in the performance tuning guide, they are in the administrator's guide. Run the query again. So 7 has gone up to 8 waits, and then a third time so now it's stable here in this, because this is always one or two rows, it's a single block. The query time is not noticeable to you. For this user, querying one row from a one block table is 0.002 seconds, but you could imagine maybe 10 rows from a 1000 block table or 10 rows from a 10 block table, and you could imagine 100 users running such queries from both instances. what if node 1 was updating the first row and node 2 wanted to fetch so if node 1 were to update this row and then node 2 wanted to execute this update, it would also have to wait. So you could also see that wait event. There will be a new wait event. Maybe you would want to test out that event or and see what wait event occurs. So there's a lot of different wait events for global cache: consistent read, current reads, two-way where it has to go to the resource directory, three-way is where the resource directory is one instance but the block is in a third instance, so you could have a three-way wait elsewhere. That's the maximum. It doesn't matter whether you have 2 nodes or you have 8 nodes or a 16 node rack. The maximum you'll have is a three-way wait. So remember, if you have blocks being updated from one row, from one node, and you have the same block, not necessarily the same row, but the same block being requested by another instance in your rack environment. In my demo, I just scaled to 2 users and 1 block. You could scale this to 100 users and thousands of blocks. You could scale to 1000 users and 100 blocks. You could imagine the concurrency weights here. You just have 100 blocks, but you have 1000 users want to read those 100 blocks frequently. You'll save a lot of global cache weights. Thank you.